Welcome back, statistics. We're going to do another exciting video at MHP. So I've crossed a lot of things out here because obviously we're not going to do them. So I'm not going to do bell work. We're just going to go straight into the lesson for time's sake. If we were on campus, in class, then we would do this activity. It's actually a really, really fun activity with left and right hands, but we're not going to do that right now, obviously. And then this Desmos activity, I'm actually going to postpone for the next video. So go to the next video and do that Desmos activity here. And then we're going to just summarize. That's the agenda. I hope you're okay with it. You don't really have a choice. Before we actually get started, you can start writing down the essential question and everything. Before we actually get started, I want to make it clear that you should be on Math Excel. You should be on Math Excel. You should be doing homework and everything. If you have yet to do the 2.1 through 4 assignments on Math Excel, if you have yet to even touch the orientation, if you have yet to even do the Math Excel login assignment on Google Classroom, then you are behind. You are behind. And you need to get your act together and do school. We are in school right now. And you will fail this class because you just were lazy and didn't actually do what you needed to be doing. Okay, this is actually a very simple class. It doesn't need to be hard. Just pay attention, ask questions. You'll be fine. Okay. As you are still writing it down, I want to explain one more thing to you. In statistics, as you notice, even from the last lesson, there are a variety of different things, a variety of different problems. And in these problems, it's not really like find X or do this. It's really just interpret this. Okay, what does it mean if that says this? What does that mean? Given the nature of statistics and those types of questions, they're often phrased as paragraphs instead of just actual like number problems. So sure, in algebra you have 9x plus 2 equals 7, find x or whatever, and that's true, you have that. But in statistics we don't really have something like that. We have paragraphs full of information, and we're given data sets. Because we're given paragraphs of information and data sets, the way the notes are laid out are just different. So let me explain what I mean here. All right. If you look, this is something that's obviously it's a note packet because it says a note packet, but this is something I'm actually going to give to you via Google Classroom online. Now, do you have to print this out? No, you don't. But if we were in class, I would actually give this to you. I would give this to you, and you would actually fill it out and everything, fill out the blanks. Why? Because it's so much easier than just going through all the notes that I have on the screen, writing down every single thing. And maybe in algebra or geometry, you could probably get away with that, maybe. But in statistics, you cannot. So I have to provide you the notes, like for the vast majority of the time. And this is one of the things that I'm going to provide you. Now, if you don't have access to a printer, then I don't really know what to say. There's other means that you can try to figure out in order to print this off if you need to. If you need to go to the library, or I'm sure if you want to go to the front office, I can print these off and hand them to you if you really want these. If you don't have access to a printer, but I found that most students do have access to a printer and they can print this off if they need to. Okay. But do you absolutely need to? No, you don't absolutely need to. You have the video that I'm going to go through, and that should be really good. That should be sufficient for you to go through your homework. Okay? So what I'm saying is this will actually be inside. This will be attached right here. So at the very bottom, you can just find, oh my gosh, why isn't this? The very bottom, I will have this attached. In fact, I'll probably just attach it now. So just pardon me. Okay, so this is attached now. My apologies. So now you can see that this is at the bottom. Now we don't have a video for day 3. I'm skipping that. That's just the pretest. So we don't need a video for that, but do the pretest on Math Excel. That's still worth a grade. It's right underneath the orientation. Make sure you do the orientation, the pretest, and then this assignment right here, the 2.1 through 4 was the last I went through that in the last video. Make sure you do that, because right now we're on 2.5, measure of position. Okay, so the measure of position, we'll actually see it right here. That's the video I'm going through, and then this right here is your note packet. Feel free to print that. You can even type in it if you want to. You can type like the words and everything. You can make a copy. Obviously you can't edit it, but you can make a copy if you want. So if you go over here and then go to File, make a copy, then you can copy it down, and then you can actually fill in these blanks, okay, for whatever I have. All right, so you can follow along essentially. Okay, this is a really short lesson. It's actually not going to be this long. Why is this doing this? Okay, it's actually not that long. It's actually just 2 pages because I stop at 2 pages. So all the other stuff, all the other fluff is just I'm not using. I'm only doing 2 pages. So front and back, that's what I have here, the key. Okay, I will honestly probably post the key as well. I usually don't want to, but I probably will post the key. So right here, actually, I'm just going to do that right now. Okay, so I did post the key. I'm sorry, I'm pausing the video and going back and forth, but this is the posted key. So go ahead and click on this, and it'll actually take you to the PDF key of the whole lesson. So you can use this to help you. Okay, that's what I'm saying. You can use this to help you. Is that better? So I may still post the actual note packet just in case those of you who want to actually print it out and follow along, so you have it. Or maybe I'll just post the key, and so you can fill this out. I don't know. Okay, I don't know. So I'm still kind of debating, but you still need to take notes either way. Is my point. You still need to take notes because you have focus notes due this week, this Friday. It's on not Math Excel. It's on Google Classroom. So Google Classroom. If I get rid of this, let's schedule this. You still have focus notes right here, okay? You need to click that, and you still need to take them, okay? So that's the point. Yes, I have a key right here, sure, but that doesn't mean you're off the hook for taking notes. You still need to take notes somehow. You can use this template and just copy everything down. That's great, but somehow you still need to take notes. I'm giving you so many resources, guys. It's really unbelievable. I mean, not only am I giving you a video, but I'm giving you a key. I'm giving you all these resources on Math Excel, and I'm giving you additional videos, not from me, but from other mathematicians and other math teachers on Google Classroom. There's really, to me, no excuse to fail this class, because this class is really one of the easiest math classes you'll probably ever take. Even though it looks complicated, I assure you it's really not. So feel free to use that. I think what I'll more than likely do is keep the key posted, and I'll also post this note packet just in case for you guys. But you can definitely submit this, is what I'm saying. You can write down the essential question. You can take, do all the notes and everything, copy them down from the video or from the key, and then just post those notes on Google Classroom. This right here, you can do that if you want to, and I would accept those notes. Okay? All right. With that said, let's start. Okay, how do I calculate measures of position? This is your essential question. How do I calculate measures of position? Well, measures of position are really just box and whisker graphs, okay? And unfortunately, like I said, we won't be able to do the activity, but that's okay. We'll do the box and whisker graphs by hand without the activity. So first of all, we need to understand what are quartiles. Quartiles come from what are called fractals. Fractals are numbers that partition or divide. That's what partition means. Like part ways, partition or divide an ordered data set into equal parts. For instance, the median is a fractal because it divides the order set into 2 parts. If you want to find the median, you have 2 parts here. Because the median is a fractal, we can then use that in trying to understand these quarters, these quartiles. So that means it's broken up, data sets can be broken up into 3 quartiles, Q1, Q2, and Q3. Divide an ordered data set into 4 equal parts. Now, what's really missing here, it's 4 equal parts, but it won't. You really only need the 3 quartiles. So I'm going to get into that when we start drawing it out. So about 1/4 of the data will fall below the first, on or below the first quartile, Q1. 1/2 of the data will fall below or on the quartile 2. That's the data set. That's the median of the data set. And about 3/4 of it will go on the 3rd quartile. Okay. Now, if you're filling out the notes, if you want to print that off, that's great. Just print off the first 2 pages, and then you can actually follow along and write this stuff in, the underlined stuff. Perfect. Let's go through our first example, yeah? So a number of nuclear power plants in the top 15 nuclear power producing countries in the world are listed. Find the first, second, and third quartiles of the data set. What do you observe? Well, first of all, you can only find the quartile data sets, quartiles of the data set if it is in order. So this is not in order, which is kind of frustrating. So we need to put it in order. So I have 6, 7, 8, 9, 10, 15, I have 16, I have 16 again, I have 20, I have 20 again, 23, 23 again, I have 50, 58, and then 104. So these are all the data, the whole data set actually in order. Now, and only now, can we actually find our median. So how do I find my median? Well, like I said, I usually cross them out. So when I kind of go through this, I cross them out. And now I have this as my median. So this is what we call Q2. Okay? What does that mean? Well, that means the rest of the data, all that data, okay? All that data is one section of it, and this is another section of it, okay? Now, how do I find Q1? Okay, now Q1, I basically do the exact same thing, but with this section. So with this section, I need to find the median. And how do I find Q3? With this section, I find the median. So I basically do the exact same thing. I try to find the median, and then my median here is 23. So then quartile 3 lies with 23. Okay, that's quartile 3. And then right here, if I want to find the median, 9, not the median, the quartile 1, sorry. So quartile 1 is 9. Okay, that's basically the middle set of the data. So it lies right on it. All right? Good, sweet. Let's go on to my next example. Now, use technology to find quartiles. By technology, I mean, of course, Desmos. The tuition costs in thousands of dollars for 25 liberal arts colleges are listed. I actually went to a liberal arts college. It was really great. Use technology to find the first, second, and third quartiles. What do you observe? Now, the cool thing about this is when you use technology, most of the time on Math Excel, you'll have this list, and they'll have this little blue thing here that you can click on. Okay, we kind of saw it in the last video. If you clicked on that and copied the data, then you can paste that data into Desmos, and that's exactly what I did here. So this data right here is pasted into Desmos. Sorry, not that data. This data, Y1. So this data is pasted into Desmos here. Because this data is pasted in Desmos, this is 25 list, okay? Now, the cool thing is, if I want to find the quartiles, all I need to do is type in stats in Desmos, stats Y1, because that's my list. It can be anything. This list can be anything, but in my personal list, if you click on this link, which I just did, then that means you will see that I put Y1. This could be X1, this could be whatever. I basically labeled this list Y1 and I put it as a list in Desmos. It doesn't need to be Y1. I hope that makes sense. Okay, and what this will give you is a variety of things, which is amazing. What it gives you is all of this. It gives you the min. Well, the min is just not quartile one. The min is the smallest data set. Okay, the min is the smallest data set. It will give you quartile one. It will give you the median, which in this case is quartile two. It'll give you quartile three, and then the max, the highest data set. All I needed to do was type in stats, parentheses, and then y1. Because remember, y1 is the my actual data set. Does this need to be y1? No, it could be a1, it could be f1, it could be j1, c1. It doesn't matter. Just type in y and then literally the number 1 right after, and then you get that. Is that great? It's pretty good. So then when we go here, when we go back, we want to find the first, second, or third, we already have that. So what is quartile 1? Quartile 1 equals 26.5. That's taken directly from Desmos. 26.5, right there. Quartile 1. Now, that's quartile 1. If I want to find quartile 2, because it says find the second quartile, first, second, and third, quartile 2 is just 32. Again, this is also what we call the median. Quartile 2 is the median. Okay? And then quartile 3, because that's also what it asks us to find, that's 40.5. Well, how did I get these numbers? Again, guys, it's literally just plugging into Desmos. You will soon find out this whole course pretty much is plugging stuff into Desmos. I mean, seriously. So I get frustrated when students just don't really take stats seriously, and then they fail it because it's literally just plugging stuff into Desmos. I can't emphasize that enough. It's that simple, seriously. You're just plugging stuff into Desmos, and then you're getting answers out. There's no tricks, I promise. And so if it's that easy, I don't know why you wouldn't just do it and just get the right answer. That's amazing, okay? And this data set helps us out a lot because then we can break these data into different parts like quartile 1, quartile 2, quartile 3, and start performing business on them, like statistical analysis and seeing which one is more profitable, which one will fall in the next year, and so forth. Business, financial accountants use this literally all the time. All the time. All right, so that's the second example. I hope that was clear with Desmos. If not, just email me. Now, what does the interquartile range mean? The IQR literally just means this. IQR equals Q3 minus Q1. That's what that means. Interquartile range, IQR. So that means it's Q3 minus Q1. So this is what you're probably really familiar with when you're a child. The maximum and then the median is quartile 2. This right here is quartile 3. This is quartile 1. And then the IQR is this little box, your box plot. And then these are what we call the whiskers, right? Or used to call them the whiskers, okay? Right here, and then right there. Those are the whiskers. And this is the box. So we're going to start drawing some of these, but honestly, Desmos does handle it most of the time. So let's kind of go through this. What are the guidelines? This is the second page of the notes. What are the guidelines in trying to solve for the IQR? Well, first of all, find the first and third quartile range. I mean, you can't do the IQR unless you first solve for that. I mean, that's just how it is. Okay, you need to first solve for the first and third quartiles. Second, the quartile range, you need to actually calculate it. Third, you multiply the IQR by 1.5. Now, why do you want to do that? You want to multiply it by 1.5 because you really want to find an outlier. So I'm going to underline that here. The reason why 3 is necessary, the multiplication here, is because you want to see if there is an outlier. Okay? Outliers are important. So instead of just like blindly guessing, well, that looks pretty far away, I think it's an outlier, so maybe don't care about it that much. It's really, you can use your math and it will actually tell you whether or not that point is far away and meaningless. because if it is meaningless, then I'm not going to worry about it. That's what an outlier is, a chilling outside point. Okay, so let's follow these steps. I'm going to follow these steps pretty much exactly, okay, in these next couple examples. So identifying an outlier. All right. Find the interquartile range of the data set in example 1. Now, example 1, I've already put that onto Desmos. So this is example 1 right here. Which one? The 15 element list. Now, the cool thing is this. You ready for it? You can do the exact same thing. You can do the exact same thing on Desmos. You can just do stats x1. So if this list is already in Desmos, then you can just do stats x1 and voila. You literally have all of these things. So what's my quartile 1? My quartile 1 is 9. My quartile 2, my median is 16. And my quartile 3 is 33. And this is just for example 1. That is amazing. Okay, so then let's go back here and let's start labeling this stuff out. So my quartile 1 we found was 9 because I just used Desmos for it. So I just, again, plugged it in, plug these points in. This is the points from example 1. Those are the points from example 1. The data set from example 1. I plugged them in. I labeled it just x1. And I went down here and just typed in stats, parentheses, x1, x, and then literally right after type in 1. There's no underscore. It's just x1, x1. If you don't believe me, x, and then I'm just going to type in 1. Boom. That's all you need to do. Okay? So after you do that, you're going to go back here, and you're going to actually solve the problem. So you need to know the quartiles. So Q1 is 9, and then Q3 is 33. Perfect. Okay, so that means if my IQR equals Q3 minus Q1, this is my IQR. Okay, what is my actual IQR? Well, it's 33 minus 9, which equals 24. So 24 is my actual IQR. This is step 1. Okay, well, technically this is step 1, and then this is step 2. This is step 1, finding it, and step 2 is finding your IQR. Step 3 then is multiplying the IQR by 1.5. So that means 1.5 times my IQR. And this is going to be my formula here, so I'm actually going to cloud this. This is technically step 3, which means this equals 1.5 times 24. Because 24 was my IQR. Remember, this is what I found to be my IQR. What does that equal? This actually equals 36. Okay, so that's 36. And then step 4 in our guidelines, it said subtract 1.5 IQR, this number, 36, okay, from Q1. So that means I'm going to take Q1 minus my 1.5 times IQR. Now remember, I already found the 1.5 times IQR. I'm just writing this formula down. So then we take, this equals my 9 minus, because that's Q1, minus, what do we find here? 36. So I take 36. And this equals negative 27. So that means if I have a data set, a data point that goes beyond negative 27, that means that there is an outlier. So I'm going to write that. So data that is less than negative 27, that means go beyond. That means it's like negative 28, negative 29, negative 30, negative 33, negative 50, negative 100. So anything that's more negative, less than 27, is what we would say is an outlier. But here's the thing, we don't have any data sets that is negative 27 and less than that. So we are solid with that. There's no data sets that are an outlier on that side. Okay? Sounds good? Okay, now step 5 is going to be adding. So step 5 is the Q3 now, plus your IQR. Whoops. Your IQR times 1.5. Now again, we already found Q3, that's 33. We already found the IQR times 1.5, which we said was right here, 36. So 33 plus 36, not times. That's a rather large number. So we're going to take 33 plus 36. This equals 69. What does that mean? Okay, so that means data that is, greater than, data that is greater than 69 equals an outlier. Data that is greater than 69 equals an outlier. Do we have any of those data sets in this example? We do, and it is actually 104. Where did I get 104 from? If you go back to example 1, you'll see that we have 104 there. Okay, so this right here, 104, is my actual answer. That's the outlier. We only have one outlier. If you still don't see where I got 24, that's okay. Or 104, right here. 104, that was part of my list from example 1. I got that from example 1. That is an outlier. Okay? So that's how you find outliers, and you'll only have a couple of questions on that. So I'm going to erase. Now, drawing a box and whisker. I love this. This is my cat, Lol. I call her Lou because Lucy is sometimes too long when I'm trying to yell at her. So I'm like, Lou. And she's like, Meh. I love that cat. She's so fat. She's the fattest. So drawing a box and whisker plot. Here are the instructions, the guidelines. Drawing a box and whisker plot. We already know technically how to draw a box and whisker plot, but I'm going to just basically go through it real quick. Find the 5-number summary. That is how you do this. So stats. And then just say X1 on Desmos. How do you find the 5-number summary? It's just desmos.com. This right here will pretty much give you that 5-number summary. That's what we call the 5-number summary. So right here, this is what we call the 5-number sum. We also call this the 5-number sum. Why? 1, 2, 3, 4, 5. Okay, so that's the 5-number sum. Construct a horizontal scale that spans the range. So this is the horizontal scale right here. That's the horizontal scale. Okay, and then plot the 5 numbers on the horizontal scale. Okay, draw a box above the horizontal scale like this. Draw that box from Q1 and Q3. So this is Q1, that's Q3. It doesn't matter how big you go, how small you go. And draw a vertical line at the box of Q2. So this should be vertical lines here, vertical lines here. So in case you don't know, this should be a vertical line, that should be a vertical line, and that should be a vertical line. And then you can connect your quartiles together. Okay? Then all you have to do is just draw whiskers from the box to the minimum and maximum. So if it's all the way over here, you just draw right there. If it's all the way out here, your maximum entry, you draw. Will you have to do these by hand? No. You know why? Because we have Desmos. That's why. Okay? So let me actually erase all this. And let me go to our next example, our last example. Draw a box and whisker graph plot that represents the data set in example 1. Okay, so I go over here. Example 1 was X1, right? This is X1. I already did my 5-number summary. Now watch. All I have to do is say box plot. I type that in, box plot, X1. Type it in, box plot, X1. And then all I have to do is click that and boom. There it is. Boom, there it is. Right? What does that mean? So if I actually click on this, if I zoom up, actually I like that better. I'm just going to keep it. This minimum value should be whatever our minimum value is here. And I think our minimum value was 7, okay, or 6. Our minimum value is 6. So actually let me erase all this and I'll kind of draw it out. So this right here is 6 and this is our min. This right here is our quartile 1 and this is 9. How do I know these? Right here, remember 5-number summary. This right here is quartile 2, and that equals 16. That's also what we call the median, right here. This is 16, quartile 2. Quartile 3 right here, quartile 3, that equals 33. Okay? And then our max all the way out here is 104. This is our max. Is 104 an outlier? It is. Okay, we already found that to be true. This is an outlier. All right? That's literally it. There's nothing else for you. Okay, that is box and whisker graphs, box plots. Not too shabby at all. Not too shabby. So this is basically what it is from the textbook, but we already went through it. So let's go through the summary points. I'm going to remind you of your homework, that you need to make sure you complete your homework, your Math Excel orientation, your pretest, the 2.1 through 4 basic stats on Math Excel, because that's a participation grade. Your Learn Statistics Desmos activity from the very, very first video. That's also worth a grade, and it was actually due Monday, so that was due Monday, 8/3. In this lesson, though, we learned a variety of things. First and second, third quartiles of the data set and how to find the interquartile range. Represent the data set graphically using a box and whisker plot. That is measures of position. Those are measures of position. So we will do the Desmos activity, but that's going to be the next day, so hold on tight to that. Obviously, you don't need to do the worksheet because we're not in class. Don't forget honors contracts, the orientation, and the login. Okay, go to Google Classroom. Don't forget to type this in, your username and password. If you're already on Math Excel, great. Go here, type in your username and password. It's worth a grade. If you have yet to get on Math Excel, you are falling behind. Make sure you go to Math Excel, complete this assignment, like I said, complete the pretest, the orientation right there, and then now you should be completing the 2.5 measures of position. I don't want to waste any more time, so if you have any questions, email me. Until then, I'll see you next time.